Hey guys, welcome back to Better C Sharp. Today we're going to be talking about LINQ, which is one of the best parts of C Sharp. Honestly, LINQ is like the thing I miss the most when I'm working in other languages. LINQ just makes it so easy to work with collections that it's almost like cheat codes for programming. I mean, it's seriously so nice. So uh, I made some slides for this video because there's like a lot to cover and I didn't want to get lost along the way. So what we'll be covering though is what LINQ is, kind of your code before and after linking, so to speak, um, using some more complex LINQ and like how you can like chain things together, and then writing our own LINQ style extension methods. So what is LINQ? It's a collection of interfaces, methods, and stuff in the System.Linq namespace that make it easy to work with collections of data. It stands for Language Integrated Query, and that comes from this syntax right here that you see, where it's like this from number in numbers where number blah blah blah. So it's kind of like a query language. We're not really going to be talking about that in this video. I personally don't like the query language because it kind of departs from the C# style, if you will. And it just, it's a jarring thing. And really, I think using the extension methods like we see down here is a much easier way to do it. And also, like, it's more homogeneous with the code around it. It's like, it doesn't jump out and look really weird in the rest of the C# code, right? So all the interfaces that we're going to talk about implement IEnumerable, and so we're going to be mainly looking at the IEnumerable interface. So I have a video about IEnumerable, so if you don't know what that is or why it's important, you can go check that out. I'll put a link up here. And then so LINQ, like I said before, is extremely useful for working with collections. It might be the most useful collection library in existence, and I'm not exaggerating there. I haven't used, especially the most useful compiled one. Rust is really good too, and I'm sure that I'm sure there's really good ones in JavaScript and in Ruby and stuff like that, but those aren't really compiled languages. So strictly speaking of compiled languages, LINQ is, in my opinion, the best that you can get. So that's why it's worth talking about. So let's move on. So IEnumerable, just a quick recap, is a forward iterating read-only interface over a collection of T's. So the IEnumerable of T, and that's the one we're going to be talking about today. So an example might be if you have numbers, an int array of numbers, you can get a read-only or an enumerable of that. So it's just a read-only interface that is forward iterating over that array, right? You could also write it like this. So, and it may sound limiting to just have forward iteration and not random access, but honestly, most of the time, that's all you need. Almost all the algorithms that you use on a regular basis, you just need to go from beginning to end and do something with them, right? And that's why the for each loop is so nice, because that's what you end up using all the time, because it's just so common. And so this is what the for each loop desugars to, right? And so this is kind of the style that IEnumerable gets used, under the covers. This is how it works. So, and this is kind of what you can do. So you can get a sum of all these numbers just using the IEnumerable interface. So LINQ is this set of code, and they're at the bottom on crack. It's there's a whole lot of them. So it's a bunch of extension methods in the System.Linq namespace, and they give us a set of easy to perform, nicely wrapped, common operations that we can use on collections that implement IEnumerable of T. And we don't have to write them ourselves. And we know they work, and we know they're performant. And we if you look at the source, maybe I'll put a link to that in the description. At least there's two really you can look at. There's the the old .NET framework reference source, and then there's also the .NET Core or .NET 5 source is available on GitHub, and I'll put those links in the description. They're specialized. So for instance, if you do a count on an IEnumerable, it's not going to go through each of the elements. It's going to first try and cast it to a collection. And if that works, if it is a collection, then it can just use the cached count that collections inherently have. So they're performant, and they're easy, and they're very readable, and it's just really nice. So for instance, this code right here written in LINQ in like the traditional for each style, like we're gonna get all the people that have 4 or more letters in their name. So we're gonna have to go through all the people, get their name, see if the length is greater than 4, and then add them to another list. Add their name to another list. Well, that same thing could be said this way using LINQ. So we're saying like, get some people. We're gonna take their name, and then we only want the names where it's greater than 4. So it's kind of the same thing we're doing here. And that's kind of the whole purpose, because this, like, once you get used to it, this is so much more readable than this, because, you know, who knows, like the naming could be bad. Like, this is a well-written for each loop, but like the naming could be bad. Like, it's much easier to read this way. It's more concise. So we're going to go over most of the LINQ methods and just kind of how they go from a for each style into a LINQ style and kind of what that looks like. So we're going to be using this example a lot where we've got a person class, and that person has like a name and an age. And then we have an array of persons that would be called people. And then we're going to have like an example of like what that would be using a for each, and then what that would be using LINQ. So where is probably the most commonly used one for me. It's used as a filter. So you want all of the people who have their name starting with B. And so this is what that would look like in for each, you know, for each person and people. If the person's name starts with B, add them to a list, and then at the end you've got the list. Well, with LINQ, you just have people.where person, and you got a lambda here. These are called predicates. They're like the language construct is a lambda. You're passing it into an argument called predicate. I believe it's called predicate. That's like commonly what they're referred to. And this gets executed on each person, and if it comes out to be true, then they get added to the list there on the left, this enumerable on the left. And this is all lazily evaluated, and we'll take a look at that when we get to implementing our own. So this is like what it would be like after. And to me, this is a lot more readable. It's like, give me the people where the person's name starts with B. Like, I don't think you can get any more readable than that, like in C#. So like, you know, we've got these 7 lines versus this 1 line that literally says what it does. The people that start with B equal people where person dot name starts with B. Like, literally as concise as it gets, right? So that's super awesome. Let's move on, because we got a lot to go through here. Select is probably the second most common one for me. It's kind of a map from other languages. So like if you're using like Rust or JavaScript or whatever, this is map basically from other languages. It is used to take a sequence of input elements and turn them into a different sequence of output elements. So from one thing into another thing. So that could be like, you know, you take in some numbers and you give back double that number, or you take in some numbers and you give back string representations of those. So it's from one thing to another thing. So for instance, given a collection of persons, select their names. So the before this might be for each person and people, we add the name to the list, right? And then we've got the names. Or we could just say the names are the people, select the person's name. Like, that's super concise. It's right on target. Says exactly what it does. And this is like also important to note that the input and output are not particularly related. They can be of different types. They can be like totally unrelated. You can just return random numbers, for instance. So that's also of important note. The any and all extension methods, I use these quite a bit. Basically, this says, any says, you know, if any of the things in this collection meet the criteria, it'll return true, otherwise false. all is the same thing, but it's for all of them. So if they either all meet the criteria or they don't all meet the criteria. So we have an example. Determine if all the people are under age 30. So for each person in people, if the person's age is greater than 30, then it's not true. They're not all, if it's greater than 30, they're not all under 30. So that's kind of our quick breakaway. So all 30 or under in LINQ would be people.all person.age is less than or equal to 30. So 30 or under, less than or equal to 30. The opposite of that could be they're all 30 or under if any of them are greater than 30. So these are like kind of opposites, right? So all or any are kind of like opposites in a way. So you can use them to get the same result with the opposite logic, basically. So that's that. I think that's pretty straightforward as well. The min, max, average, and sum, these are like reduction functions in a way. I don't know if that's not the technical term probably, but like you have a collection and then you get one value out of it, right? So like you have a collection of numbers, the average is only one number. It's not from a sequence to another sequence. So so aggregates, not aggregates. In SQL they would be called aggregates, I guess. But anyway, min, max, average, or sum. So they have default predicates for like the built-in numeric types. And it's not really predicates, they're just like default implementations, I guess, for like int, for instance. I guess. I haven't looked at the source for this, so they probably just have like a default implementation of IEcomparable or something like that. But anyway, so before you would have like for each person and people, you would keep up with a count and a sum, and you would add their age up, right? And then at the end, the average would be the sum over the count. But after, like with LINQ, this would just be like, oh, and that should be a double average. But this right here, double average, is just people.average of the person's age. So you can give it the thing that you want to average as well. But like if you have numerics, you would just do like average of, you don't pass in a predicate, you just call average and it does what it's supposed to do. So cool. We'll move on. So first or default, last or default, and count. And actually I left out single and single or default here as well. But these give simple access to the beginning or ending elements of a collection, as well as counting items in a collection. They can also be given a predicate to determine the first, last, or count where some condition is true. So just like the where clauses and whatnot, or the predicate for a where call, there's these return true or false, and it'll give you the first or last one that does, or if it's a default, null, you know. So for instance, right here, if we want to get the last person in the collection where the person's name starts with a B, we would do for each person in people. And then if the name starts with B, we overwrite it, and we just keep going. We keep going. We keep going. If we wanted the first one, we would just break out. But since we want the last one, we just keep going and overwrite it. If we never get one, then it remains null. The exact same behavior with this right here. So we want the last starting with B would be people.LastOrDefault, where the person's name starts with B. Like it's super easy to look at, super easy to reason about, very easy. So another example might be, let's count all the people that have more than 5 letters in their name. So right here, we would have to keep up with like a count of people. We have to go through each one of them, check if their name is greater than 5, and then add to it. But down here, we're just saying, hey, more than 5 letters is people count where the person's name length is greater than 5. So it's like super like easy to read, easy to reason about. So very cool. Cast and OfType. So casting is a little bit weird with a collection, right? Because you could have collections of things that, like you could have a collection of a base class or interface with different actual types that implement those base classes or interfaces, right? So for instance, you have a list of vehicles and some of them might be trucks, right? So for instance here, like given a list of vehicles, we want to try and turn them all into a truck. That would be a cast. So what cast does is it'll go through every one of them, try and cast it to whatever the destination type is, in this case truck. And if that fails, it'll throw an exception. OfType is kind of the more lenient version of that. So it'll go through each one, and if they can be casted to that type, it'll do it and add it to the list. Otherwise, it'll just skip. So what you end up with is like, here, like if not all of them were trucks, but some of them were, you would get like, here's all the trucks out of the list. But it didn't like throw an exception. So before it would be like we get a list of trucks, and then for all the vehicles, if like this is cast, like we're trying to turn them all into trucks, we just like straight up cast. And this is obviously going to throw exceptions if they can't be casted to the type truck. So, and then the after is just trucks is vehicles.cast to type truck. So super concise again. Like this is going to be a theme, right? Like it's way more readable like this. So in my opinion. And then this is like the OfType. So given a list of vehicles, let's get all the helicopters. And so before we would have to make a list of helicopters, and then for each one of the vehicles, if the vehicle is a helicopter, then we can add it to the list. And then the LINQ version of that would just be vehicles.OfType helicopter. So this would be all of the helicopters that were in the original vehicles list. So that might not be all of the vehicles, but it'll be some of them, or maybe an empty list. So who knows? Depends on the data, right? And then we have order and OrderByDescending. These, oh man, I'm so thankful for these, right? Because if you were given an IEnumerable of something to sort, like you can't, there's no sort on there, right? So like if you had a list, you could call sort, and like list has a sort method, right? I think anyway, I don't ever call it. So you would have to like call toList, or maybe if you're like feeling lucky, you can try and cast it to a list, but that seems like suicidal. But if like, so what you would have to do is actually go through each one, and this, I don't know what kind of sort this is. It's probably, I don't know, probably bubble sort. But so you'd go through each one, and then like you'd have to like go through the list and like put it in the right spot, right? But instead of that, we can just say, hey, let's order by their age. This is sorting a collection person by age. So there you go. Yeah, pretty easy. This one is like way more readable, way more readable, and reusable, right? You don't want to have to write this every time you want to sort something. So okay, so GroupBy. This is another one that can be complicated, right? And you don't want to write it yourself every time. So this allows easy groupings based on some key. So what you get out is an I grouping from a LINQ GroupBy. And that's going to be basically, it's going to look kind of like this. Like you're going to have a key that is the type of the thing you're grouping by. And then you're going to have a collection of the things that are in that group. So in this case, we want to get a group of people by the first letter of their name. So we want to sort people into groups based on the first letter of their name. So we'd go for each person and people. If we don't have that person's first letter yet, we're going to add a new entry into our groups, and then we're going to add them to it. So, and then at the end, we've got them all grouped up. Yeah. So then afterwards would just be like, hey, let's group by the person's first letter of their name. And I'm using an index here. You'd probably want to use first, but like we're talking about LINQ, so I'm like trying to keep it one concept at a time. So this is like how you can combine LINQ methods to get stuff done, right? Because the things that you actually want to do are usually more complicated than just one of those things. So like, what if we wanted to get the letter of the alphabet with the oldest on average people that have that letter as the first letter of their name? So like we got a list of people, we want to group them up by the first letter of their name, take the average of the ages for each group, and then see which one has the oldest people, average people, right? So that would be like a lot of code if you had to write that yourself. But really what we want to do is this set of steps, like group everyone, average the ages for the group, order the groups by the average age, take the first one. And there may be even like a simpler way to do it than this. Like this is just like I wanted it to be concise, so I did it like this. So like people, group them by their first letter of their name, and then we want to select a new anonymous object, which is going to be the letter, which is the key. So the key, when you're grouping by this, the key is going to be the type. The type is going to be the type that you group by. So this is a letter, right? A character of a string. So the letter is going to be a character, and that's going to be the key of the group. So we've got the group, and then for each one in the group, we're going to get the key, which is going to be the letter, and then we're going to average the group's contents, right? The collection of the group by their age. And so that says summed, it should be average. I originally did that with the sum. But then we're going to order them all by that average age. And this is like an anonymous class, right? So we don't even have to care about making a class for this. Like if you wanted to write this out, you know, you might end up wanting to do that to make it less confusing. But since it's all rolled together like this, we don't even have to worry about it. And then we want to get the first one because that's going to be the highest one, right? And then we can write it out. So we get the letter T and the average age of, it's not going to be 42. That was the sum, but you get the idea. What else do we have here? Okay, and the predicates can be separate methods. So like if you don't like the idea of putting it as a lambda, like right in line where you're calling it, you can actually have it be a separate method. So like anything that fits that delegate, right? So this right here returns a bool and takes in a person, which is what a where call expects, right? So let's take a look at doing some of our own LINQ methods real quick, and then I'll wrap up from there. So let's see. Let's get let's go ahead and clear out of that. We'll go. Let's LINQ. Let's say our LINQ or something like that, right? We'll make a new project. So .NET new console. Oops. And then we'll go in here and we'll write some of our own LINQ methods, which will be fun. So, or maybe we'll just re-implement some of the existing ones. I don't know. So we go in here. So what the LINQ methods are written like is so LINQ and using system collections generic. So let's say we had like a list of numbers. We'll just do odd ones, right? So we'll say we'll have an array of numbers. And it'll be like 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's actually just get rid of this. Okay, cool. And then let's go ahead and just write out join, and we'll say something like that. Does that work? See if that works before we move any further. Okay, cool. So yeah, you guys can see that. Perfect. And so using LINQ, we might want to be like, you know, odd ones. And then I'll write the type actually, so it's important. IEnumerable of int odd equals numbers dot where and mod 2 equals 1, right? So let's write out the odd ones. Actually, let's do both of them. Okay. So this should give us, yeah, so the bottom one is all the odd numbers, right? But what if we didn't have a LINQ and like, let's say the LINQ namespace didn't have what we want. We could write it ourselves, and I'm going to show you guys how to do that. So all of these are just extension methods. So basically what you do is you write a class, or you use an existing class. So we'll do public class enumerable ex for extensions. I usually title my classes that. There's no, you don't have to do that, but that's what I do. And then it has to be static. And then extension method also has to be static. So public static, and we'll say IEnumerable t, because we want it to be generic, right? So that's what we're going to return, and we're going to say where. And then for it to be an extension method, you have to do this enumerable t source. And then we want to allow them to pass in like a predicate. So we'll do func. I can never remember if the return type is first or second. I think it's second or last. So I think it would be int bool predicate, right? And so what is we got saying up here? Not contain a definition for where. This oh, sorry, it's in the wrong. Yeah, we didn't actually specify the generic part. So now we actually just have to work this out. So the way this actually works, so you could write it a few ways, but we'll do it using yield to build like our little state machine thing under the covers. So basically we're going to do for each var input in source, and we'll just say, or let's call it element. We'll just say if predicate of the element, then we will yield return the element. Boom, there it is. What's going on? T to int. Oh, sorry, not int. It needs to be a T. You guys should have called me on that. And if you did, good job. So that is basically our implementation of where. And so 1, 3, 5, 7, 9. Yeah, that's correct. So, but you know, you can also get a lot more complex. Like one that I find myself often needing is like, I want to batch something into sets of IEnumerable by some batch size, right? So like, what if you like, you know, public static IEnumerable, and what we want to do actually is return another IEnumerable inside this of t, right? So we want a collection of collections, and we're going to call it batch, and it means a type of t, this IEnumerable of t, and then, you know, like an int batch size. And like I haven't written this in a long time, so it'll probably be wrong, but we're going to try it and we'll work through it. So in here you might do something like list of t current batch, new list of t, and we know we want it to be a batch size, right? And then what we want to do is do something like source.get enumerator. Somebody's calling me. Let me make sure it's okay. All right, we're good. And then while enumerator.move next, we'll say something like, well, you know, we can do this in a for each actually. We'll do it in a for each. For each var element in source, we'll just keep int count equals 0. We'll just say count plus, and then something like you know what? I think actually there's another way I might want to write this. So let's do for int I equals 0, I is less than batch size, I plus. No, I don't like that either. Let's go back to here. So count plus plus. Okay, so what we want to do is current batch dot add elements, and then if current batch dot count equals batch size, then we want to return current batch, right? And then we will clear it and set count back to 0. Something like that. This doesn't cover our situation where we have like some left over, I think. So let's say we came in here and we had 5 elements and our batch size was 2. So we come through, we say, okay, count is 1. We're adding the first element. This is going to be false. And so we're going to come back up here. Our count is now going to be 2. We got 2 of the elements. This is going to be true. We're going to give back the batch. Really, I think we probably want to call toList because we want a copy of it, I think. This actually would require us to have link. Let's clear this out. And then after that, we can, oh, you know what? Actually, we can do this without. We can just say yield return current batch, and then current batch goes new list of batch size. And then count 0. And honestly, we can just come back and take this out of here. We don't need that, right? Because we're adding up the count. So if current batch, yeah, we don't need it at all. Okay. And then we would just want to yield return current batch, I think, at the end. Let's see what that does. Who knows if this is going to work or not. So then let's say we'll say var, but it's going to be IEnumerable of IEnumerable event. We'll write it out. Just to make it clear. Batches equals numbers.batch, and we'll say we want them in batches of 3. Like that. Actually, let's do 5. That way we have one missing from the second batch. And then in batches, and we'll say console.writeLine, and we'll say string.join, and then batch. Is that gonna work? Yeah. Batch ID equals 0. Batch index. Yep. Okay, and then we'll just say batch index. Yeah. Let's be good. Blah, 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 blah. Okay, is that right? I think that's right. We will try it out. Who knows? I have no idea if this is going to work. I haven't put that much thought into it. Hey, it works. So like we just wrote our own extension method to batch things into batches. Like, so now we took like, one thing and made it into 2 things. We could go the other way too. Like, this would be basically SelectMany, but we'll do one more because we got a little, well, we're running low on time, but we'll do one more just in case. So static IEnumerable of t, and we'll just say combine. But this is basically SelectMany. IEnumerable of t, right? Source. And then int. We don't need a batch size. So here, what we want to do, our generic parameter. Here, what we want to do is like for each var batch and source. For each var elements in batch, yield return none, right? So this would be going the opposite way. So if we took our batches and put them back into this, they would come out all together. So let's actually reverse. Batches equals batches dot reverse, and then we'll say combined is batches dot combine, right? And then we'll just put our console.writeLine for batches. Or sorry, combined. So now we should see the batches come back together, except in reverse order. So yeah, 6, 7, 8, 9, 1, 2, 3, 4, 5. So this is kind of how you write your own extension methods. And that can be super, super helpful to get your own link-like methods for working with collections. So I hope this has been helpful. I hope you guys use this and let this clean your code up so you don't have all the for eaches everywhere with a bunch of custom code. I hope it helps deduplicate your code. That's the main goal here of LINQ, right? So that's all I got. If you guys enjoyed it, hit the like button. If you guys want more, hit subscribe. Yeah, hope you guys have a good one.